It's been a blessed day to be with you, my mathematics learners. Today, we are going to solve rational inequality. I am teacher Elizabeth Kitola, your guide for today. Rational inequality is an inequality involving rational expression. It uses the symbol for inequality like greater than, less than, greater than or equal to, and less than or equal to. Let's have example number 1. Solve the given rational inequality. 3 over x minus 2 is less than or equal to negative 1. Let's take the solution for the given inequality. Number 1, put the rational inequality in general form. R of x all over by q of x is greater than 0, where greater than can be replaced by less than or equal to, and greater than or equal to. In the given, you can see that your negative 1 transposed to the other side of the equation becomes positive, and then you have there 0. Number 2 is to write the inequality into a single rational expression on the left side. Set the numerator and denominator equal to 0 and solve. The values you get are called the critical values. Let's have for the numerator, x plus 1 equals 0. Transpose positive 1 to the other side becomes negative 1. X equals negative 1. For your denominator, x minus 2 equals 0. Again, transpose negative 2 to the other side of the equation becomes positive 2. Your x is now equal to 2. Number 4. Plot the critical values on a number line, breaking the number line into intervals. We have there the given number line since our values of x are negative 1 and positive 2. Substitute the critical values to the inequality to determine if the endpoints of the intervals in the solution should be included or not. From the given original rational inequality, we are going to substitute the value of x by negative 1 and 2. If the value is true, then it is included in the solution. If it is false, then it is not included in the solution. Step number 6 is to select test values in each interval and substitute those values into the inequality. Note that if the test value makes the inequality true, then the entire interval is a solution to the inequality. If the test value makes the inequality false, then the entire interval is not a solution to the inequality. Number 7, use interval notation or set notation to write the final answer. Since you have values of x for x which are negative 1 and 2, and since negative 1 is a solution in the set, therefore you will write open bracket. And since 2 is not included in the solution, you will write close parenthesis. Let's try to answer example number 2. Find for the values of x. Let's take example number 2. Solve the given rational inequality. 3x plus 1 all over by x minus 1 is greater than or equal to 2. Step number 1. Put the rational inequality in general form. So you have r of x over q of x is greater than 0. Transpose positive 2 to the other side of the equation becomes negative 2. So you will have 3x plus 1 over x minus 1 minus 2. Number 2. Write the inequality into a single rational expression on the left side. Given 3x plus 1 minus 2 times x minus 1 all over by x minus 1 is greater than or equal to 0. Simplifying, you will get x plus 3 over x minus 1 is greater than or equal to 0. Step number 3, set the numerator and denominator equal to 0 and solve. The values you get are called the critical values. Let's take first the numerator. X plus 3 equals 0. Transpose positive 3 to the other side becomes negative 3. So your x is now equal to negative 3. For the denominator, you have x minus 1 is equal to 0. Transpose negative 1 to the other side of the equation becomes positive 1. Therefore, your x is equal to 1. Step number 4. Plot the critical values on the number line, breaking the number line into intervals. In your given, you have x is equal to negative 3 and x is equal to 1. Step number 5 is to substitute critical values of the inequality to determine if the endpoints of the interval in the solution should be included or not. So you have your original given 3x plus 1 all over by x minus 1 is greater than or equal to 2. Substituting when x is equal to negative 3, therefore it is included since the given is true. For x is equal to 1, it is not included and it is undefined. Step number 6 is to select test values in each interval and substitute those values in the inequality. So when x is equal to negative 5, it is true. When x is equal to negative 1, it is false. When x is equal to 3, it is true. Note that if the test value makes the inequality true, then the entire interval is a solution. Next, if it is false, then the entire interval is not a solution to the inequality. For the last step is for us to use interval notation to write the final answer. That's all for today. I hope you learned something on solving rational inequality. Don't forget to subscribe if you think you are learning from my channel.